Okay, so this is the third locus that we're discussing, and again, let's understand what it means. You don't have to rote learn it. Z minus Z1. What does Z minus Z1 mean? Vector from Z1 to Z, right? A connection between Z and Z1, and then the mod of that vector going from Z1 to Z. What does that give you? That gives us the magnitude of what?
The circle.
It gives us the length of the vector. It gives us the length of the vector, which means you get the distance from Z1 to Z. This mod of Z minus Z1 gives you the distance from Z1 to Z. Now, same over here. What does Z minus Z2 mod will give you? The distance from Z2. And then you're saying the distance from Z1 to Z is equal to the distance from Z2 to Z. Now, under what circumstances would you have Z somewhere where Z will always be the same distance from Z1 as well as Z2?
Radius.
It has to be a perpendicular bisector of the line joining Z1 and Z2. And this you have done in O-levels. The locus of the point, which is always equidistant from two fixed points, is the perpendicular bisector of the line joining the two fixed points. This you have done in O-levels. And same is over here. The locus of Z is the perpendicular bisector of the line joining Z1 and Z2. As simple as that. So let's try this out. So in general it would be something like this. Let's say Z1 is here and Z2 is here. So first you connect Z1 and Z2, and then the perpendicular bisector of this line connecting Z1 and Z2 would be your locus. Because see, now you can say it doesn't matter where Z is. Z can be anywhere on this line. No matter where Z is on this line, it will always be equidistant from both Z1 and Z2. So it has to be on the perpendicular bisector of the line joining Z1 and Z2. As simple. Are you good?
Yes.
Yes. Okay. So let's try this out. Again, first of all, you have to bring it to the form so that you can identify which are the two Z1 and Z2. So this is Z minus 1, and this is basically Z minus I. So Z1 is 1 and Z2 is a minus I. So now first mark these 2 points. One and minus I. First, let's mark these 2 points. So let's say it's somewhere here, minus 1 and 1. So one point is at minus 1, minus I, and the other point is at Z1. So this is your Z1 apparently, and this is your Z2. And I need to find Z where Z is, that it would always be the same distance away from Z1 and Z2. So it's going to be the perpendicular bisector of the line joining. It's going to be a perpendicular bisector, make a dashed line between Z1 and Z2. And a perpendicular bisector, and I'm sure everyone can realize that the perpendicular bisector is going to pass through the origin.
Yes.
So, it's going to be something like this. This blue line is the locus of Z. Just for the examiner, please also take the midpoint of Z1 and Z2, where you're passing the perpendicular bisector from. Equal is passing through the origin, the other one is this midpoint. I think the midpoint is clearly half minus half. Just mention the quarter of midpoint as well.
Z minus I instead of.
Because I need to identify what exactly Z1 and Z2 are. See, we need to stick with this form. Z minus Z1, Z minus Z2. So, see, Z minus 1 means Z minus 2. Z1 is 1. Z2 is not an I. Z2 is actually a minus I. So only then if you would write in this form with a Z minus, only then would you be able to identify what exactly the other fixed point is.
So how do you say Z2 would be minus 1? Over here in the sketch.
How would Z be minus 1?
No, like Z2 would be minus 1, right?
Z, this is Z1,
Yeah.
and Z2 is a minus I, so here is Z2 minus 5. This is the original minus 1. On the imaginary axis, this is minus I. But we don't just write I on the axis, we just write 1, 2, 3 because this is all imaginary. So these are all I's. Like this is 0, then this will be I, 2I, 3I. So this is minus I, minus 2I, minus 3 and so on. Can we also find the Cartesian equation of the line? The Cartesian equation of the locus, the blue line that we just found?
Yes.
Let's find that out. Need to find the gradient. The point is already there, it passes through the origin.
Origin and the other
Yeah,
part is
you
there.
have already 2 points. You can find the gradient, get the gradient of the line.
Minus
The gradient is minus 1. Check.
Yes.
You have 2 points, 0, 0 and half or minus half. You can find the gradient. Gradient is minus 1 and clearly the y-intercept is
0.
0. So I guess the equation
Y
is
minus
minus
x.
6. Good. Okay, let's try this out. Z minus 3 mod Z minus 2i. So clearly Z1 is 3 and Z2 is a 2i. So let's first mark the points 3 and 2i. So this is 2r and this is 3, right? The connection between 2 and 3 and 2r. And then the perpendicular bisector. So it is going to pass through the midpoint of this line, and I guess the midpoint of the line would be at 1.5 and 1. Right. So it's going to pass through that. Something like this. Something you don't know the right answer is fine. You can just use this point to get the equation. This point is what? Is 3 by 2 comma 1.
Yes.
And you can find the gradient very easily. You find the gradient of this line In the negative reciprocal, you have the coordinates for this 0, 2 and 3, 0. Check. So I guess the gradient of the line joining Z1 and Z2 is 2 by 3 minus 2 by 3. Check. The gradient of this line. This is 3, 0, this is 0, 2. Check, you must be getting minus 2 by 3. So the gradient of your line is playing 3 by 2 and passing through 3 by 2, 1. Now I think you can find the equation easily.
So we have to find the equation of the perpendicular line.
Yeah.
Are we all good?
Any questions?
No.
Okay, so the three loci are done. Now let's move into combinations of loci. Okay, so see all these loci that we did. Notice something, they were all equations. Question 12, question 11, as well as question 10, these are all equations. These, on the other hand, are all inequalities. So, there's going to be, if you are asked to sketch an Argand diagram, an inequality, it will not be just a line, it's going to be an area. Because see, here we are trying to say, and you understand why I'm saying it's an area. Argument of z minus 2, which means a line connecting to a z, and that line making an angle what? They haven't given one angle. They're saying the angle lies between pi by 3 and pi by 4, which means it's somewhere between that range. So that range is going to give you an area on the Argand diagram. See, so you have to shade that area. Let's mark 2. Let's say 2 is here. Now it says between pi by 4 and pi by 3. Let's first make the pi by 4 line, and that line is by them included. So pi by 4 line is something like this. This is a pi by 4 line. Everyone's okay with that? From 50 angle. Oh, pi by 4? Okay. And this is, we need to make it, see, z is somewhere, z when connected to 2 is somewhere between the angle pi by 4 and pi by 3. Now pi by 3 angle is something like this. It's a 60-degree angle, so it's going to be more than 45. It's going to be something like this. And by the way, that line is not included. That line is not included. It has to be less than pi by 3, not equal to, can't be equal to pi by 3. It means the z point cannot lie on the line. It can lie on this line because it equals pi by 4. So it can, z can be found on this line, but z cannot be found on this line. It has to be within that line. So this is going to be, you will have to make a dashed line, not a full one, because that line is not included. And your area of interest is this. This is your area. This angle is pi by 4, and this angle is pi by 3. So your z can be anywhere within this area, or it can be exactly on this line. That's it. So your locus is not just a line, it's an entire area. So in inequalities, this will always be the case, you will come across an area. Are we all good? Okay, now I hope you recognize this as a circle. Z minus Z1 or let's say equal to 3. So that would be the circle. Right? First let's do the Z minus Z1 mod so that you know exactly what Z1 is. Z minus 1 plus I mod. So your Z1 is 1 plus I. So you will make a circle around 1 plus I, and the circle will be a 3-unit circle, 3-unit radius, but the circumference of the circle will not be a full line. The circumference of the circle will be a dashed line because
it's not included.
Because 3 is not included. It's not equal to 3. It's within 3. So you have to mark an area, but the boundary is going to be a dashed line. Okay, so let's say 1 plus I. Let's say 1 plus I is here. Somewhere. Let's say 1 plus I. Now around this, I need to make a circle. 3 units. So something like this. Okay, so this is 1, 1. This is clearly 4. This is a minus 2. This would be 4, and this would also be minus 2, right? Now, it's not going to be a full line, it's going to be a dashed line because 3 is not included. So z cannot be on the circumference. Z has to be, is z going to be outside the circle or within the circle? Why within? Because the distance is less than 3. If the distance would have been more than 3, then the area would have been outside the circle. So, shade everything within the circle and you have your required area. So what we are trying to show is that z can be found anywhere within the circle but not on the circumference. If this was less than equal to 3, then I would have made a full line from the circumference showing that z can be anywhere within or on the circumference of the circle. But in this case it can't be on the circumference. Are we all good? Any questions? Okay, try this out. Now there are two loci here. One plane is a circle, and the other one is like the one that we just made in part, like 2 lines. And there will be some, okay, when you're making multiple loci, then it says and, it means you need to find a common area. There will be an overlapping, and you need to get the common area out. So let's first make the circle. Clearly the circle is centered at
0.
the origin. Yes. Now, see this time the circumference is included because it's C0 less than equal to 5. So circumference included, so we make a full line. Now what about these? Pi, minus pi by 6 and pi. Two more lines we need to make, and that is about 2. So 2 is somewhere here, first of all. This is 2.5, 2 is somewhere here. And two lines extending from 2, one at an angle of minus pi by 6, which is minus 30, I guess something like this. And the other one is at pi, 180 degrees, which I believe is somewhere here. We agree on that? And your required area has to be an overlap. So you need to satisfy both loci. So it has to be within the circle and also has to be between these two angles. Between minus pi by 6 and pi and within the circle, so I believe this is your area. Within the circle as well as between minus pi by 6 and pi.
Why can't it be the other area?
Okay, why can't be the other area? Because your angle goes from minus pi by 6 to pi. If you take this going from here to here,
That's
it would be
pi.
minus pi by 6 to minus pi. That would be the angle, because then you're going from minus pi by 6 all the way towards positive towards pi. So your angle is increasing. In that case, it would be minus pi by 6 to minus pi. And in that case, it would be minus pi to minus pi by 6. Small angle would come first. Are we all good? Can you move on? Okay. Let's just do this hurriedly. Now there are two circles and two lines.
Yes.
Let's just make them, and it's good to make the bigger circle first. Two circles, both centered at the origin, luckily.
तो दोनों शुरू हो गए डॉटेड
दोनों क्या?
डॉटेड
हाँ, दोनों, yes, दोनों dotted होंगे. There won't be full lines, yes. Let's say this is the 4 wala circle. Clearly this is 4, 4. And let's make another circle of unit radius, something like this. And there are two lines, both originating from 0 again. From the origin.
So you get one is dotted.
Oh yeah, it will be dotted. So this will also be dotted. So now there are two lines, and by the way, these two lines are full lines. Minus pi by 4 to minus pi by 3. So first let's make minus pi by 4. Minus pi by 4 is somewhere here from the origin at an angle 45. This is minus pi by 4. And the other minus 3 pi by 4 is like this. And your area, it has to be greater than 1 outside the smaller circle, less than 4 within the bigger circle, somewhere in between, but has to also be in between these two angles.
This is a beach guy, so
within the bigger circle,
Outside.
outside the smaller circle, and within the two angles. Going from minus pi by 4, going basically from minus 3 pi by 4 to minus pi. This should have been the other way around. Should have been minus 3 pi by 4 to minus pi. Any questions? Are you all good? Shading? Yeah. It's outside one, greater than one, so it's outside the bigger circle, smaller circles, less than 4 inside the bigger circle, in between somewhere here. Then it has to be between these two angles. Minus 3 pi by 4 to minus pi by 4.
Greater than 1 and you want it to be above.
It's above the smaller circle. It's not inside the smaller circle. Above the smaller circle and within the bigger circle. So you will go outside. It's from minus 3 pi by 4 to minus pi by 4.
It says greater than 1.
हाँ ये उल्टा लिख दिया है, should have been here, this should have been here.
C is greater than 1.
Yes, you are outside one.